Hey guys, and welcome back to another A-Level Maths Made Easy video. This time we're going to be tackling the modelling with differentiation. So a fairly tricky topic that comes up in both Year 12 exams and Year 13 exams. And as I said, it can really screw over a lot of students. And I think the reason why is this is one of the brand new skills in A-Level. So in GCSE we don't really have anything like these types of questions, hence why it's pretty tricky in A-Level to do it. So without further ado, I've gone every past paper question that's come up so far. I've left pretty much every question in the textbook for you guys to do. Just so you know, if you join the Discord, we have solutions to all of the textbook answers as well on there, just for your enjoyment, perusal, whatever you want to call it. But without further ado, let's jump straight into it. So, a large tank in the shape of a cuboid is to be made from a 54 meter square of sheet metal. The tank has a horizontal base and no top. The height of the tank is x, and two opposite faces are squares. So the volume of the tank is given by this expression. Cool. Now this might seem a bit strange. Here's the thing that you need to do, and realistically if you're in Year 12 and watching, this is definitely something you need to work on. Year 13 you tend to be a little better at it, but you need to draw diagrams always. So it's a large tank in the shape of a cuboid. Even if you don't know what these are, just draw a good old-fashioned little cuboid. And I'm going to even make it 3D, although my 3D shapes are not... Actually, no, that's not too bad. I've seen worse by myself. And it tells me that it has no top. Now, sometimes when it has no top, I see some students get a bit confused because they include a top. So I like to just do a little like hashed line, just to show that that side doesn't exist, so to speak. Okay, so the height is x, so let's put x like that. And the two opposite vertical faces are squares, which means the base here is also x, because this cuboid, this rectangle, 3D rectangle, its sides are x and x because the height and the depth must be the same because they are squares, right? And the sides of a square are all the same. And it doesn't tell me how wide the shape is, so I'm just going to call it y, because x and y makes 100% sense to me, right? And it says, show that the volume is given by. So here's what I would do. And I'm well aware that model answers tend to not follow this exact process, but I think this makes more sense. As I would write down, how would I work out the volume? Well, I would do y times x, or x times y, however you want to do it, but it'd be x squared y. Now, this doesn't really look like this, does it? So, what have I missed out? Well, remember my golden rule that I said all throughout GCSEs, all throughout A-levels? They never give you information you don't need. And if you notice, there is a 54 meters squared that I haven't used. And this is generally where students get stuck. Now, I want to point out, you get a mark for this anyway. So if you get stuck, at least you have one mark, that's not bad. Is using this other information they give you. Now, this information can be anything. Sometimes it's a surface area. Sometimes it's the depth of water. Sometimes it's... Sorry about that, I had to sneeze. Sometimes it's even the cost per gram of metal used or something crazy like that. But the idea is that you're going to somehow use this information to eliminate the variable you don't need. In this case, I don't need y. So, what does this mean? And this is the tricky bit. Well, 54 meters squared, that is, of course, some kind of area. Right? Now, it's telling me that this shape is made of metal. Now, if I think of a box, right? If I think of a box, the surface of it is the material it's made of. So in short, this 54 square meter is actually the surface area of the cuboid. Take a second to really think about that. If I have a sheet of metal, if I wrap it around a box, that becomes the surface area. So if I work out the surface area of this shape, that should be equal to 54. Well, let's try that. The surface area is going to be, well, we have this front base, xy, or yx, however you want to write it, and there's two of them, right? Because there's also one on the back. Okay. Then we have the square side, so x times x, that's x squared, and again we have two of them. Boom, boom. Then we have the bottom side, which again is xy, but we do not have two of them, and this is where people make mistakes. They put a 2 here. Because the top side is empty, it's hollow. If you imagine like a fish tank, and you take the lid off, that's the kind of shape we're talking about right now. So there is no 2 here. And we know that that equals 54. So that means we have 3xy plus 2x squared equals, oh god, 54. 4. So what I'm going to do is I'm going to move... I want an equation for y, so I can sub it in. So I'm going to move everything that isn't y over. So minus 2x squared from both sides. 3xy equals 54 minus 2x squared. I'm going to divide both sides by x. So let's do by 3x, right? 54 divided by 3. Can you do that? I actually can't remember. Let's see if it's 54 over 3x for now, and I'll check out my calculator in a second. And then we have 2 over 3 x. That's probably where that 2 over 3 comes from. 18. Okay, yeah, got you. Y is equal to 18 over x minus 2/3 x. And I'm going to simply substitute this into this original formula for my volume. So v is equal to x squared y. So it equals to x squared times 18 over x minus 2/3 x. So expanding this should be quite easy. X squared and then 1 over x. So that's just going to leave me with 18x. Right? Because we would have 18x squared over x. Cancel the x's, 18x. And then we have minus 2/3 x cubed. And then just do a nice check. I don't know why I said nice check. That is the actual answer. That first part can be up to 4 marks. Pretty good. Now, part B and part C, and this is something that really annoys me about some students, is when they don't get part A, they skip part B and C. You can do part B and C without doing part A. And here's the funny thing. Part B and C tend to be most of the marks. So let's say this question's roughly 10 marks in total. You get 4 for the first part, you get 6 for the next 2 in total, which is going to be 4 and 2 marks. So it's actually better for you if you just do part B and C, even if you don't know part A. So, it says, given that x can vary, use differentiation to find the maximum or minimum value of v. Here's what we're going to do. We're going to differentiate this, of course, because it's a maximum or minimum. You always differentiate with respect to whatever the variable is on the right-hand side. Okay? Another way I like to think of it is, if you have multiple copies of a variable, that's what you're differentiating with respect to. So in this case, with respect to x. And minus 2x squared. And we're going to make that equal to 0. Move the 2x squared over. Why are we making it equal to 0? We are making it equal to 0 because a maximum or minimum value is a turning point or a stationary point. That only happens when the gradient equals 0. Divide both sides by 2. Now technically, if I square root both sides, I get plus or minus 3. So which one is it going to be? Well, if I have a look at this, x is a length, which means it cannot be negative. So I'm going to take x equals 3. Is that my answer? No. Because it says, work out the maximum or minimum value of v, not of x. You need to then resub this back in to the original equation to work out what the maximum or minimum value of v is at this value of x. And here we go. I'm just going to use a calculator because I'm lazy, but laziness is fine. Better than making mistakes, that's for sure. 2/3, 3 cubed, gives me 36. That's a nice number. And I don't know if this is a maximum or minimum value yet. This should be in meters cubed, because we had meters there. I don't know if it's a maximum or minimum value yet, because of course I haven't done the second order differential. Part C, justify it's a maximum. There you go. Well, you differentiate one more time. So differentiating this equation equals just going to be minus 4x. Now, technically, to be really, really rigorous, you'd have to sub in this value of x into that equation, which is minus 12, which is less than 0, therefore it's a maximum. You have to be very rigorous with this. The mark scheme can be very, very specific. But that's it for your first question. These are hard questions. It comes up if you're in year 12 every other year or so on average. If you're in year 13, it comes up most years. So it is something you should definitely get good at, but it's 10 marks, pretty fat question, but hopefully this makes sense. Again, I think it's part A that most people struggle with, but let's go on to a couple more. With this question, it is ever so slightly different, and I wanted to show you this just before we move on. It actually gives you the equation straight away, and it doesn't say to show it. But if you look at part A, part 2, part B, part C, etc., they get a bit more interesting. So with part A, find the value of V which minimizes the cost of the journey. So it's not the minimum cost of the journey, that's part 2. So all we need to do is differentiate this. First of all, use your rules of indices in order to make this into a proper form. So V to the minus 1. I'm going to say 2 over 11V, 60. Differentiate. What does V stand for actually? Velocity, I'm assuming. Yeah. Equals minus 1500 V to the minus 2 plus 2 over 11. And again, we want to make this equal to 0. So if I move the 1500 V squared, I'm actually going to write that like this. But hopefully you can see it's the same thing. Then if I just kind of move this over, so V squared will go up, 2 will go down, 11 will go up. We have V squared equals 11 times 1500 over 2. And then square root that, and that will give me my answer for part I. Part 2 is just subbing that value back into the equation for C. So 11 times 1500 over 2. Square root the answer, and I get 90.8. Really? Okay. That seems a bit fast, to be honest. I heard that the most efficient speed is a bit lower than that, but then again, this is in kilometers per hour. Mine was in miles per hour, so that's actually accurate. Never mind. So, part 2, the minimum cost of the journey. Part 2, just sub it straight back into the original expression. I do like to actually write the whole thing out. I know that might seem a bit weird, but it just really shows the examiner that I know what I'm doing. Again, the point of the exam, this might sound weird, is not to get the right answer, it's to show the examiner you know what to do. That's the important thing. I know that sounds a bit weird. Getting the right answer should, show the examiner what to do, but anyways. And then we put A and S to the minus 1 plus 2 over 11. Answer plus 60. Gives me 93, and what was the unit? The unit is pounds, so 93 pounds for this journey. If he speeds. Prove that it's minimized by the speed found. That's actually a good point. I should have said this. We don't actually know it's a minima yet, although it does say in the question it's a minima. So if we want to be really rigorous, I shouldn't have said that. So differentiate once more. Okie dokie. dv squared. So it's going to be plus 3000 v to the minus 3. Yeah, minus 3. Panic there for a second. And all we need to do is prove it, so we just need to sub in that value. It was this value here. And you can kind of see that it's going to be positive, and so obviously it's going to be a minima. But again, writing the substitution out is very important. It's just something that they really expect you to do. 90.8 to the power of negative 3. It's a small number, but it is a positive number. Greater than 0, therefore minima. Again, can you see how the structure is the same each time, right? Well, okay, very similar, I should say. Generally, the first part is making the equation. In this question, they gave it to us. The second part is finding the finding the values that maximize or minimize something. Proving it's a maxima or minima. That's the general layout. Sometimes they give you the first part, and then the last part will be state a limitation of the model. But either way. So a limitation of the model, this is going to be different every single time. Just going to point that out. And there's a load of different things you can say. In fact, in the mark scheme, generally it would give you maybe 5 different responses, and then it would say any valid answer. So what would I say? Well, one is, technically speaking, if I increase V more and more and more and more and more, I will have infinite cost. Right? I can make this speed like 10,000 kilometers an hour, and it'll make the cost bigger and bigger and bigger. I can keep increasing V. Basically, there's no limitation on what values of V I can put in. That's one downside. 2 is it doesn't take into account air resistance, which is really, really important. 3, it talks about a steady speed. It's not really accurate for there to be a steady speed. If you guys have been in a car before, you'll know that you don't really travel at the same speed for very long. There's traffic lights, there's turning corners, there's all sorts of stuff that will affect that. Anything along those lines is really important. I personally like to do the mathematical way. 9 times out of 10, they will always predict either a negative cost or an infinite cost. Both of those things cannot happen. So just make V a ridiculously large number. Does it mean the cost is ridiculously large? Does that even make sense? That's what you need to think of. So sometimes it'll be negative, sometimes it will just be infinity. Either way, that will be a limitation that you can talk about. So again, hopefully seeing a very similar layout. We have a cylinder, very basic. Sometimes these can be very wordy. Surface area is 500 centimeters squared. Show that the volume is given by this. Given it varies. And then the same type of thing. Again, 8 out of the 12 marks, so most of the marks, actually comes from just differentiating, equating to 0, and then double differentiating. That's it. So you can get most of the marks just by doing that. So genuinely, if you want, you can even start with part B. Right? Who cares, right? But I'm going to show you how to do part A because that's the really important bit in my opinion. So we have a cylinder. Again, I like to draw a little diagram just to help me visualize what's happening. It's a beautiful cylinder. Look at that. Oh, yeah. Beautiful. Has a height h, radius r, and it's to show that the volume of the cylinder is given by blah. So the volume of a cylinder is pi r squared h. Again, that doesn't look anything like this. What letters missing? Well, here we have r squared and h. Here they just have r. So that means I need to find an equation for h. But look, they've given me an expression, a value for the surface area. So all I need to do is work out the surface area. Now, the year 13s at my school have recently done their exams, and I did hear a bunch of them asking, oh, what's the, how do you work out the surface area? How do you work out the surface area? You don't need a formula. A lot of people rely on formulas, but there's no point. If you unroll a cylinder, you get a rectangle, and you get 2 equal circles, right? That's like the net of a cylinder. The circles I'm hoping are fine. That's just pi r squared. And there's 2 of them, so we're going to do 2 pi r squared. Now, I will admit that the rectangle can be a bit cheeky, can be a bit annoying. But if you imagine a cylinder is a circle like this, and you're unraveling it so it's a straight line, that wide length is just going to be 2 pi r, the circumference of the circle. And the height is going to be, well, the height. So again, if you get a piece of paper, roll it into a cylinder, and unroll it, you'll see that the length of the rectangle is just the circumference of the circle. So that is going to be plus 2 pi r h. That's all you need to do. And that equals 500 centimeters squared. So now I'm going to rearrange for h, so I'm going to move the 2 pi r squared to the other side. So 2 pi r h equals 500 minus 2 pi r squared. We can actually divide through by, well, I get 2 pi r technically. So if I start with 500, divided by 2 is 250, so let's write the 250 first. Then it's still divided by pi r. Then we have 2 divided by 2, of course, pi divided by pi, r divided by r. So it should just be r. Cool. Subbing that into this formula that we have up here, we have v is equal to pi r squared times h, so times all of this juicy stuff. So we have 250 over pi r minus r. So the pi and the pi are going to cancel. The r squared and the r is going to cancel a bit. So it's just going to be 200r, which... Sorry, 250. That's why you always check the answer. Can I... Yeah, there we are. 250r. Just like it says in the answer. Then we're going to have pi r squared times minus r, so we're going to have minus pi r cubed. Exactly as it says, 4 marks. Pretty good, right? It's not too bad. Now part B and C, again, I'm assuming this part is actually relatively okay. Calculate the maximum. We're going to differentiate and equate to 0. So dv by dr, we have 250 minus 3 pi r squared. Equal it to 0, move that over. We have 250 equals 3 pi r squared. So if I do this all in one step now, one giant step, we have 250 over 3 pi equals r. I might sub that whole thing in. Yeah, calculate the maximum value of v. So we're not actually looking at the value here. So sub that back into this thing. Alright, it's fine. We're going to use the good old-fashioned A and S button, right? Because we're cool. So 250, again, A and S, so whatever that answer is, minus pi A and S cubed. You are more than welcome to do that in your exam. No rules against it. So let's do this. So we have 250 over 3 pi, gives me whatever that is. So 250 brackets answer. Again, I would always use brackets just because, again, paranoia. It's not paranoia if it actually is like a thing. So 858. Yeah, I'm going to say 858. And I believe that was centimeters cubed because I remember there being centimeters squared in the area. Yeah, centimeters cubed. Justify. So that's 6 marks. Calculate the maximum value. 6 marks. Crazy. Crazy. Just doing that. 1, 2, 3, 4, 5. I mean, 4 lines really. 6 marks. Pretty good. So we're going to differentiate one more time. Just to, well, I mean, because we have to. Minus 6 pi r. And then subbing in the value for r that we get is, of course, going to give us a, oops, spoilers. Let's see how I'm going to word it. Let's do it like this. And then NS. It's of course going to give me a negative number, so it's less than 0, therefore a maximum. That's all you got to do. Really, really nice question. That 6 marks is so juicy. Look at that. Perfect. And I don't think it's too difficult. So again, do B and C even if you have no idea how to do A. I would actually even recommend doing B and C, then going back to doing A. That might be a good thing for you to do. So as usual in these videos, the next 2 questions are going to kick it up a little bit. So this one looks a bit more fat. The one after this is very fat. It's very beefy indeed. So this is apparently a design for a swimming pool. Good. Bunch of stuff. Semicircle, rectangle. Cool. The area of the pool is 250 square meters. Show that the perimeter. So of course, same as usual, we're going to write an expression for the perimeter. In fact, I might write it on the side just to make it a little bit easier, and then I'll drag it over when I send the notes at the end. Well, the perimeter here, I'd have y plus 2x plus y, so that's 2x plus 2y. And then I would have the circumference of this semicircle, right? So the radius is going to be x, so it's just going to be 2 pi r, 2 pi radius, so it's just be 2 pi x divided by 2 because it's a semicircle, so it's just plus pi x, right? So again, circumference is 2 pi r, but since we're only using half a circle, we're going to half that, it's just pi r. Cool. That obviously doesn't look anything like that, but that's because they've given me the area. The area is honestly completely fine. The area is equal to, so with the rectangle, 2x times y, so it's 2xy, plus pi r squared, but again, it's that we want half of a circle. So pi r squared over 2. Over 2 equals 250. Okay, and we want to rearrange for y, so let's move that over. Yeah, we just do that, yeah. 250 minus pi r squared over 2. Divide by 2x, we get 250 divided by 2 is 125, so we get 125 over x minus, I just realised, instead of r I can put x of course because, you know, it is x. There you go. And then we have, so divided by 2x, so that'd be just pi x over 4 now. Right, because when you have 1 over 2, divided by 2 again, you can do the maths if you want, but it'll give you 1 over 4. It doubles the denominator. Subbing that back into my original, we get p is equal to 2x plus 2 times all of this. In fact, I'm gonna cheat. 2 times 125 over x would be 250 over x. And then minus 2 times all of this, so that would just be, again, it would just be pi x over 2. and then plus pi x. Now, ooh, this is, okay. Some of you may be able to see that that will simplify to the expression that I want. Now, with minus pi x over 2 plus pi x, you can treat that as minus a half plus 1, which will give you plus a half, right? So we're just kind of ignoring the pi x for now, but it will indeed give me pi x over 2. Now I'm going to quickly just move this underneath so we can do part B and C. The part B is a little tricky, to be honest. So normally when we have this kind of range, what we would do is we would sub in the big value, right? And we'd sub it into here, and it would give me an impossible answer, maybe a negative perimeter, maybe 0 perimeter, something like that. But in this case, if you look, if I sub in x is root 500 over pi, I get a value that's normal, right? It's not weird at all. Now, there's... God, lost my words for a second. The reason why this is 2 marks is because there's 2 sides of this. I would start with the x is bigger than 0. Why does x have to be bigger than 0? Well, I mean, again, this might be obvious. Because x is a length and must be positive. That gives you 1 mark. Believe it or not. Pretty good. But with this root 500 over pi, in my head, and this is my first thought, I thought, well, we never square this number. And that means it's probably not subbing into here. We never square it. But if I look over here, for my area, for example, or even over here, whatever way you want to look at it, if I sub in x into this expression, I actually get something that is impossible. So let's look at this 250 minus pi x squared over 2. And this is the working out that you would use to get your marks. If I sub in this value, everything's actually going to cancel out. So I'm going to do 250 minus, I'm going to do pi over 2, and then because it's x squared, I'm going to have 500 over pi. Cancel. 250. Cancel. I get 250 minus 250. Somehow equals 2xy. So in short, my area becomes 0. Area becomes 0. And what would happen if my value was greater than this? It would become negative. If x is bigger than square root, what was it, 500 over pi? Area becomes negative. Which is of course impossible because again, area has to be positive. So that's the actual reason. That's why this question was actually very difficult, because instead of subbing into the kind of main equation, you actually sub it into an equation that you worked out for the area, which isn't really part of the question. So I thought that was a bit of an interesting one. It's a bit tricky. Part C, find the minimum perimeter. Again, change this into a form that you can actually differentiate. So we have p is equal to 2x plus 250 x to the minus 1 plus pi over 2 x, and then dp by dx gives me 2 minus 250 x to the minus 2 plus pi over 2. Yeah, okay, there's 2 values of x. Okay, cool. Equals 0. I would move this over. Can we do... Yeah, we can't really add those two together, sadly. Pi over 2 equals... And again, we're going to write it in terms of x squared. And then moving this around, we get x is equal to the square root of 250 over 2 plus pi over 2. So I'm going to give you a second just to think about that. We've swapped the x squared and this whole thing, and then we've square rooted it. Then all we do is we sub that back into the original to find the perimeter. And again, we're going to use the good old-fashioned ANS button. Plus 250 ANS to the minus 1 plus pi over 2 ANS. And that'll give me my final answer. So let's quickly sub this in. So we have 250 over 2 plus, and then pi over 2. Yeah, that's my answer. God, I don't know why I brain froze there for a second. plus 250, whoops, that's not 50, ans to the minus 1 plus pi over 2 gives me, let's call it 59.8. And I think this is centimeters. No, it's meters. That actually makes a lot more sense. That's quite a massive swimming pool, to be honest. Yeah, 3SF. Job done. Not too bad once we got started. Now for probably the hardest one that I've seen. Okay, so a company makes drinks containers out of metal, probably called a can. Their model has closed cylinders with a base R, height h, and the capacity is 355 cubic centimeters. Yeah, so it's a can. Cool. I mean, can they be any more obscure? Maybe. So height, radius. So we've already done this one, a similar. Well, we've done the same shape before, so we should hopefully be experts. The capacity is 355 cubic centimeters. However, the metal used for the circular base and the curved side is 0.04 pence per square centimeter, and the circular top is 0.09 pence per square centimeter. Sorry. Both metals are of negligible thickness, so they don't affect the capacity is the idea there. Show that the total cost of the metal is given by that. Cool. Let's work out an expression. Now, just like in the very first question, this pence per square centimeter is all to do with surface area, right? So you have a surface area that you're going to create out of metal in order to make this can shape. Now, the circular base, that's going to be pi r squared. So what I'm going to do is I'm going to put it in brackets, pi r squared. And the curved side, remember, that's going to be the circumference of the circle. So 2 pi r times h. That's all timesed by 0.04 pence, right? Because 0.04 times pi r squared and 0.04 times 2 pi r h. Adding on, the circular top is 0.09 pi r squared. We could expand and simplify, so that's what I'm going to do. So 0.04 pi r squared plus, that'd be 0.08 now if we times it by 2, plus 0.09 pi r squared. We can put the pi r squareds together, that gives me 0.13 pi r squared plus 0.08 pi r h. But again, we have that 0.13 pi r squared, we've got that already, but we need to get rid of the h. And it says the capacity is that. Well, capacity is the same as volume. So it's pi r squared h equals 355. So rearranging this for h, we get 355 over pi r squared. So subbing that into our equation, we can now get our answer. From here, I'm willing to bet that you guys will be able to do parts B, C, and D. In fact, I would be willing to bet. It's definitely the first part that is the really tough, challenging part. 355 pi r squared. So we can cancel the pi's, one of the r's. 355 over 0.08. Sorry, times 0.08, that's the difference. It's probably going to be 28.4, but why risk it, you know? Why not just do it? So 0.08 times 355 gives me 28.4 as expected. – 28.4 over R. Job done. So again, the cost thing definitely does throw some people. But again, basically you're just doing what the question says, and I hate saying that because it sounds really patronizing, but that is effectively what you're doing. If you really simplify every A-level question down, if you follow the steps, the process, that's generally what they want. Even if it seems like something's very challenging or very weird, like we've never learned how to work out total cost. Yeah, I know, but they kind of tell you how to do it, right? It's a cost per square meter, so you need to find out surface area. Try and use that. Now on to part B and C and D. So differentiate equal to 0. Cool. Yeah, part B. C by dr. We get 0.26 pi r. That'd be minus 28.4 over r squared. I took a bit of a shortcut there, see if you can work out how I did that. Move the r squared over. Ah, good point. Okay. Times both sides by r squared. So we get 0.26 pi r cubed equals 28.4. Then all we're going to do is move that all over. 28.4 over 0.26 pi cube rooted. And did I do anything wrong? I don't think so. But it says to actually work out the value for c. So we're going to sub that back into our original equation back up here. So again, using the good old-fashioned answer button, we can work out our value. So cube root, which is that button, is 28.4 over 0.26 pi. Gives me that. Subbing it into there, we get 0.13 pi answer squared plus 28.4 over answer. Gives me 30. Does it say how many significant figures? 3 SF, so 13.1. Is that just going to be in pence, I assume, right? Yeah, pence. 13.1p to make a can. Interesting. Verify that it's a minima. Yeah, figured. Verify it's a minima. So differentiate this thing again. We get uh, 0.26 pi minus plus even. That would be 56.8 over r cubed. And if we sub in the value, sub in that into here, you will get that it is greater than 0. Therefore, it's a minima. And what's the last thing? Oh, my bad. Yeah, that was just the value of r for part B. So my answer here is actually the answer to part D. That gives us the final thing. Oops. But that's fine. Since I noticed, it's all good and I didn't lose any marks. That brings us to the end of modelling with differentiation. Fairly tricky. It's not the easiest thing in the world, but we're going to do some stats and mechanics next. But I guess that depends on when you're watching this video. We're going to do some stats and mechanics next and get through all of that. This is probably one of the hardest topics in Year 12 maths, but in A-level maths with the whole modelling and everything. But again, integration vectors, then some stats and mechanics, and we're done with the Year 12 content.